So continuing on in our second lesson of the overview track, we're going to talk about computer components. In last lesson, we discussed the evolution of computers over centuries of time, and now we're going to go in depth into the physical hardware that a computer contains. But first, I want to reflect back on something we talked about last class. We talked about what you think of when you think of computers, often these devices, and how they're all related. The iPhone, Apple computers, Nintendo Switches, Xboxes, MacBooks, and other laptops all share similar computing technology hardware. This is what they're all connected through. So let's take a deeper look at the physical technology that is involved in creating these devices. So as the first of 5 components, we have the motherboard. This is a circuit board through which all of the components of a computer will communicate with each other through. The motherboard is responsible for holding everything together and acts as the base for the computer. As you can see here, this image is obviously a very simplified version of a motherboard, and it's much more simple and basic than an actual motherboard in a real computer would look. Next, we have a central processing unit, or a CPU. This is considered to be the brains of a computer. It directly communicates to the motherboard and links communication among all of the other components in the computer. It's responsible for connecting everything and ensuring that everything functions as it's supposed to and nothing goes wrong. Essentially, the central processing unit is similar to the human brain itself and is supposed to monitor all of the actions that take place. If something goes wrong, the CPU will know about it. Additionally, major tech companies like to have CPUs that are extremely efficient in order for the computer overall to be efficient. The faster the CPU, the faster the computer. Next, we have a graphics processing unit, or a GPU. This can also be referred to as a video card by many people, and it's responsible for generating high-end visuals. It communicates directly with the display monitor to produce high-end visuals. The display monitor, like we went over last class, is simply the piece of hardware that is responsible for displaying visuals to the user. The graphics processing unit generates those visuals and ensures that the computer or the device that's being used has good visuals. Think about it this way. For all of the video games that you play or online games that you play, all of those visuals are generated by a graphics processing unit. If you want a video game with extremely detailed and good visuals, you want an extremely advanced GPU. So next time you ask for that specific video game, make sure you have a compatible device that can support its graphics. Next, we have random access memory, or RAM. This is referred to as volatile memory. It stores data regarding programs and processes that are frequently accessed. The memory gets erased every time the computer restarts, and this helps programs and games that you frequently use open up quickly. RAM can just easily be considered as temporary memory. It keeps in mind things you often access and makes sure to keep them in mind so that the next time you use your laptop or your computer, it'll quickly bring you to the same site. Example, if you often go to Safari or Google Chrome right after opening your laptop, that information will be stored in the RAM and therefore it'll be extremely efficient next time you go to open up that app. Lastly, we have storage. Storage is necessary for all computers. Modern computers use a solid-state drive or a hard disk drive, depending on which suits the device better. So hard disk drives are made up of actual disks where the data is stored, and they're much cheaper than SSDs, and it's much more complicated to use. The disk is read by a mechanical arm, which not only makes it cheaper but less valuable because this makes the device much slower and less efficient. We have SSDs, which are considered also SIM cards. They have no moving parts like mechanical arms in the hard drive, but they are much faster and you don't have to wait for the mechanical arm to physically find the data on your disk. As you may see, if you want to consider storage in a broader context, you can think of the last time you went to download a homework assignment. Where did that homework assignment get stored? Often, it gets stored in the storage data of your laptop or your computer. However, if that disk goes corrupt, all of that data will be lost and you will be left with nothing left stored on your laptop or computer. Many companies have gone to combat this issue by providing users with a sort of online drive. This can be OneDrive, iCloud, or even Google Drives, which probably most of you have accessed. This allows users to store all of their information online, not on a physical disk, without fear of them losing all of the data suddenly. That way, if the storage disk goes corrupt, the users do not have to worry about what was stored on there and simply have access to all of their files in the online drive. So we've went over all of the basic components of a computer, and now moving on to influential figures. The next two women I'm going to talk to you guys about are extremely important in the computer science field and have personally served as an inspiration to me in my hopes of becoming a computer scientist. First, we have Ada Lovelace. I mentioned her in our last lesson as the first computer programmer. She studied mathematics, which was unusual for a woman during that time. And she met Charles Babbage, the creator of the difference engine, at a party where they began their partnership in working on that engine. She's considered the first computer programmer and often is referred to as the prophet of the computer age. And she was the first to express potential for computers just outside of mathematics. Essentially, she's responsible for creating the entire field of computer science and showing others that there's so much more than just math to this field. Next, we have Grace Hopper. Grace Hopper was an American computer scientist and a Navy Rear Admiral. She also was one of the first programmers of the Harvard Mark I computer. She developed the computer language COBOL, which was a standardized language for business purposes, and it was one of the most extensively used languages throughout the world. She won a Medal of Technology in 1991 for all of her efforts and all of the advancements she had contributed to. And she was the first woman to be honored in such a way as an individual, which served to be an inspiration to young girls wanting to pursue STEM throughout the world. So these two influential figures were extremely important in the advancement of computer science. That's all I have to cover for this track. I hope you guys really enjoy the course and were able to learn something about the evolution of computers, the basics of computers, and important people in this field. If you guys have any questions, feel free to reach out to me. If you guys would like to have access to this PowerPoint, don't be afraid to send me an email and I can send you this PowerPoint. And I hope to see you guys in another track. So over here, I have my general workspace. This consists of some speakers, my monitor, my laptop, and my keyboard and my mouse. Like I mentioned last class, the monitor simply serves to display information, whereas the computer serves to send signals to the monitor and inform it on what information to display. A monitor cannot function without the help of some sort of computer or laptop. In this case, as opposed to using a desktop, I preferred to use my laptop to connect it to the monitor. Instead of working on my small generic laptop screen, I prefer to use this larger external display. Like I said, a monitor can't work on its own without some sort of connection, and I'll show you exactly why that is. When we open this laptop over here, the monitor will turn on as the connection is currently secured. But if we close the laptop and disconnect, the monitor no longer is able to function on its own. So over here we have a computer. I'm going to open it up in front of you guys just to show you what the real components will look like. So let's take it down and move it on its side. Now we can slide this cover off. And here we have what the inside of a computer looks like. Now that we've opened the computer up, we have all of the components inside. Starting off, we have the motherboard right here. This essentially is a circuit board that links everything together. Now you may not be able to see the CPU initially, but it actually exists right under this fan. Right here is the CPU, the central processing unit, something that's considered to be the brains of the computer. Now, the fan exists above this as a means to cool the CPU down so that it doesn't overheat while it's working. Next, we have the graphical processing unit, or the video card. This is responsible for displaying graphics on the monitor or your display screen. The random access memory exists right here, and it serves to temporarily store any information or programs that you frequently access on your device. And lastly, we have storage. This is a hard disk drive. Whenever you download things from the internet, such as images or documents, you're essentially interfering with the storage. Now, because of all of the components that exist in the computer, it's likely that they're going to overheat over time. So it's important that fans like this and this exist to cool down these components and ensure that your computer has the best function. Essentially, this fan exists for the unit as a whole, whereas this one is specialized for the central processing unit. So that's it for this track. I hope you guys were able to learn something about computers as a whole, and I hope to see you guys again in some different courses that I teach.